Today I want to continue talking about systems of equations. That means that when two lines intersect, they do so at a point, and our job is to find where those two lines intersect. Let's take an example, a simple one at first. So we have something like x minus 5y is negative 5, and 3x plus 5y is equal to positive 5. Clearly we can see that these two lines will probably intersect since the slopes are different. And we can solve these equations by several methods. You can graph them, and you can probably find the solution. However, that's usually not the preferred way, because usually, depending on your graphing abilities, you could make a mistake. You know, my graphing abilities are not the greatest. However, we have other methods, and one of them is, well, some textbooks call it linear combinations, and linear combinations works this way. It means that you add the two lines together, and the goal is to eliminate one of the variables, therefore making it easy to solve for the other variable. So here, if we were to add the first line with the second line, we would end up with 4x plus 0y, or just 0, giving us a solution of x equals 0. And 0 is a good solution. Sometimes students see that and they think, oh wait, you know, x is nothing, but 0 is a perfect number. So we substitute back into one of the two equations. It doesn't really matter which one. We'll do the bottom one just for this time. 3 times 0 plus 5y equals 5. As you can see, 3 times 0 is 0, and then 0 plus 5y equals 5. Now 0 doesn't add anything to this expression, so we can just write it as 5y equals 5, or 5 times 1 is 5, so y has to be 1. So here we have a nice solution, and lines intersect at the point 0, 1. So this is a good problem to start with. Continuing on with another simpler problem. Suppose we have 4x plus 3y equals negative 2. And then my second line would be negative 4x plus 3y is equal to positive 14. Again, the idea is to eliminate one of the variables. As you can see, the x will eliminate pretty easily if I add the 2. So x's cancel out, or you can say add up to 0. And the y's will give us 3 plus 3 is 6y. And this will give us a positive 12. 0x is just 0. 0 plus 6y is just 6y equals 12. And 6 times a number gives you 12, and that happens to be 2, right? That gives us 12, so then y equals 2. Substituting this back into one of the two equations, I'll use the top equation this time. 4x plus 3 times 2 is negative 2. That means that we're going to get 4x plus 6 is minus 2, and then 4x then becomes negative 8. As you can see, then the only way you get a negative 8 is to have x is equal to negative 2. So our solution set will be negative 2 and positive 2 here. And this is a very straightforward problem. However, sometimes the variables do not cancel out right away fairly easy. So I have an example here that does just that, because let's see, suppose then I have something like 3x plus 4y is negative 13. Second equation gives us 2x minus 3y equals negative 3. And here, as you can see, if I add the two equations, nothing cancels out. So we need to find a common multiple here. So here we have a positive and a negative already. So we can try to eliminate the y variable. However, 4 and 3 do not cancel, so I need to find the common multiple, which is in this case 12. So I need to multiply the top by 3. And the bottom equation I multiply by 4. This gives us 9x positive 12y equals negative 39, I believe. The bottom equation gives us something like 8x minus 12y equals negative 12. Now you can see, if I had to combine the two equations, 9 and 8 would be 17x. These two will add up to 0, and these two will give me a nice negative 51. And of course my students will jump and say, well, Mr. Camarena, number 17 does not go into this number until, and then they try it, of course, and they always say, oh, okay. So 17 goes into 51 and negative 3 times. So here's our x value, which we'll use over here to solve for the y value. So we're going to use the bottom equation here. It's going to be 2 times negative 3 minus 3y equals negative 3 there. So that we have negative 6 minus 3y equals negative 3, adding 6 to both sides right here. Cancels the negative 6, so negative 3y equals 3, and of course y equals to negative 1. So giving us a solution of negative 3 and negative 1. And this are 3 simple examples that you can use to do your homework.